Alright, I think I'm live on both platforms. Perfect. Welcome to Bite Me, where we're squashing bugs one bite at a time. Today we're going to be finishing chapter 7. We have 7.4 and 7.5 to finish today, and that should be the end of chapter 7, which is modules, crates, packages, all that jazz. So let's get into it today. I've actually been working so hard on that in my mini Rust series. I'm just throwing this promo in. Go look on my YouTube channel. You're gonna see, I think it's called, what is my mini Rust series called? Let me double check. I thought I knew. It's under a specific playlist. My channel. Okay, it's called Rust Mini Project Series Smiling Friends Edition. Alright, I don't know that I blanked out on what it would be called. Anyway, let's jump into this chapter. It's bringing paths into scope using with the use keyword. Okay, I'm pretty sure last time we were talking about modules and module trees and a bit of packages. I'm not positive if we went into depth about packages, but we might be going in depth about packages today. So now we're going to be using the use keyword instead of the mod keyword that we were using last time. All right, having to write out the paths to call functions can feel inconvenient and repetitive. In listing 7-7, whether we choose to the absolute or relative path to the add to waitlist function, every time we wanted to call add to waitlist, we had to specify front of house and hosting too. Fortunately, there's a way to simplify this process. Now we can create a shortcut to a path with the use keyword once they use the shorter name elsewhere, everywhere else in the scope. Okay, in listing 7-11, we bring the create front of house hosting module into the scope of eat at restaurant function so that we only have to specify hosting at to waitlist. To call the add to waitlist function in eat at restaurants. So it's telling you that we don't have to specify the whole scope. We can just specify a portion of it and we can still find the path. So now we have mod front of house. We're making mod hosting public, the pub keyword. So we have pub function add to waitlist, which is now public to the parent function, to the parent files. We use create front of house hosting, and then we do pub function eat at restaurant hosting add to waitlist. Since we already kind of know the path, we just have to utilize hosting and then add to waitlist was the function that we're using. Adding use Adding use in a path and scope is similar to creating a symbolic link in the file system. By adding use crate front of house hosting in the crate root, hosting is now a valid name in the scope, just as though the hosting module has been defined in the crate root. Paths brought into scope with use also check privacy like other paths. So if they're not public, other folders, parent folders, or anything like that may not be able to see it. You have to make it public. And that's what we were talking about in the last video. So you can check that one out. And that one talks about mod. Note that use only creates the shortcut for the particular scope in which the use occurs. Listing 7-12 moves the eat at restaurant function into a new child module named customer, which is then a different scope than the use statement. so the function body will compile. Okay, so we have a mod front of house, we have pub mod hosting, pub function, add to waitlist, we use create front of house hosting, and then mod customer, public function, eat at restaurant hosting, add to waitlist. So it says this is confused because the eat at restaurant function into a new child module named customer. Okay. So they changed the path, which is then a different scope than use statement. So the function body won't compile because over here it was within hosting, right? Use create front of house hosting, add to waitlist. Now we moved it into customer mod. So we moved the path into a different mod, which is customer, and now we are just using the same path and we're thinking that it's going to find it, but it won't. So that's why he's confused over here. This code does not compile. The compiler error shows that the shortcut no longer applies with the customer module. Now, it says use the unresolved module or unlinked create hosting, or use. Use create hosting. So it's telling you that this is not valid, this is not a valid path, and it can't find it. Notice that there's also a warning that use is no longer used in the scope. To fix this problem, move the use within the customer module too to reference that the shortcut in the parent module with super : hosting within a child customer module. Okay. I think super is also used as a shortcut. So whatever hosting is, whatever path that hosting has, if you put super before it, even if you change the parent modules or files, you're still able to have that same path. So creating idiomatic use paths. In listing 7-11, you might have wondered why we specified use create : front of house : hosting and then called hosting : add to waitlist. In eat at restaurant, rather than specifying the use path all the way to add to waitlist function to achieve the same result as in listing 7-13. Now mod front of house, and we have a public mod hosting, and then we have a public function which is add to waitlist. We use create front of house hosting add to waitlist, and then we do public function eat at restaurant and then add to waitlist as we call it. We're calling the add to waitlist function here. Although both listing 7-11 and listing 7-13 accomplish the same task, listing 7-11 is idiomatic way to bring a function into scope with use. I wish I kind of went into what idiomatic means. I feel like that's something that not a lot of people would know, and I'm one of those people. Maybe we can look it up into Claude, my best friend Claude. Claude, what does idiomatic mean? Alright, load. What does idiomatic mean in Rust? Want to put in some more layman terms so that it makes a little bit more sense. It says idiomatic Rust means writing code in a way that Rust community and ecosystem expect it to be written, using the language conventions, patterns, and features in the way that they're designed to be used rather than just writing code that merely compiles and works. Okay. I feel like that's a good explanation as to what idiomatic means. Alright. So, where are we? So although both 7-11 and listing 7-13 accomplish the same task, listing 711 is idiomatic, a way to bring the function into scope with use. Bringing the function's parent module into scope with use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined while still minimizing repetition of the full path. Now, the code in listing 7-13 is unclear as to where add to list waitlist is defined. On the other hand, when bringing in structs, enums, and other items with use, it's idiomatic to specify the full path. Listing 7-14 shows the idiomatic way to bring the standard library's hash map struct into scope of a binary crate. So we use the standard collections. We use standard collections hash map, and then we do a function main let a mutable variable called map bind to hash map : new. So we're creating a new hash map. We're specifying map with dot notation to insert 1 and 2. There's no strong reason behind this idiom. It's just the convention that has emerged, and the folks have gotten used to reading and writing Rust code this way. The expectation of this idiom is if we're bringing two items with the same name into scope with use statements, because Rust doesn't allow that. Now, listing 7-15 shows how to bring two result types into scope that have the same name but different parent modules and how to refer to them. So we have a use standard format, use standard IO, then we have, which is input output, we have function, which is function 1, and we have a format, : result. Function 2 has an IO, : result as well. Now, as you can see, using the parent modules distinguishes the two result types. If instead we specified use standard format result and use standard IO result, we would have two result types in the same scope, and Rust wouldn't know which one we meant when we said result. Okay, providing new names with the as keyword. There's another solution to the problem of bringing two types of the same name in the same scope with use. After the path, we can specify as a new local name or alias for the type. Listing 7-16 shows another way to write the code in listing 7-15 by renaming one of the two result types as, or using as. So this is an alias, or just another name. Use standard format result and then use standard IO result as IO result. So we're utilizing this name instead of putting IO and then result, we're doing IO result. Function 1 shows that just result, so we're using standard format result, and then we're using IO result as a second name or an alias so that we can see the difference between in the code. In the second use statement, we use the new name IO result for the standard input-output result type, which won't conflict with the result from the standard format, which we've also brought into scope. So the compiler can differentiate between the two of them, even though they both say result. Listing 7-15 and listing 7-16 are considered idiomatic, so the choice is up to you. Re-exporting names with pub use. Now, when we bring a name into scope using use keyword, the name is private to the scope in which we imported it. To enable code outside the scope to refer to the name as if it's been defined in the scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope, but also making the item available for others to bring into their scope. Now, listing 7-7 shows that the code in listing 7-11 with use in the root module changed to pub use. So, all right. So now we have mod front of house. Within that, we have pub mod hosting. We're using a public function called add to waitlist. Then we use pub use create front of house and then hosting. And then underneath that, we have a pub function called eat at restaurant, which is hosting : add to waitlist. So before this change, external code would have to call add to waitlist function by using the path restaurant : front of house hosting add to waitlist, which also would have to require the front of house module to be marked as pub. Now that the pub use has re-exported the hosting module from the root module, external code can use the path restaurant hosting add to waitlist instead. So we made it public, and I guess it will be able to use it as well. Okay, let's see. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. For example, in this restaurant metaphor, the people running the restaurant think about front of house and back of house, but customers visiting the restaurant won't think about those parts of the restaurant in those terms. With pub use, we can write our code with one structure, but expose a different structure. Doing so makes our library well organized for programmers working on the library and programmers calling the library. We'll look at another example of pub use and how it affects the crate documentation and exporting a convenient public API in Chapter 14. Using external packages. In Chapter 2, we programmed a guessing game that used an external package called rand to get random numbers. To use rand in our project, we added this line to the cargo.toml file, which is rand equals 0.8.5. Now, so adding rand as a dependency in cargo.toml tells that cargo to download the rand package, and any dependency is from crates.io, which is the open source crate platform that Rust uses, and make rand available to our project. Then, to bring rand definitions into scope of our package, we added the use line started with the name of the crate, rand, and listed the items we wanted to bring into scope. Now, recall that in generating a random number in Chapter 2, we brought that the RNG trait in scope and called the rand : thread underscore RNG function. So you can see that this little portion was actually within our guessing game. We have the use of rand : RNG, and then function main let secret number equal rand : thread RNG, and then generate range, which is this range. Okay. So members of the Rust community have made many packages available in crates.io, and pulling any of them in your packages involves these same steps: listing them in your package cargo.toml file and using them with the use to bring items in the crates into scope. Note that the standard or STD library is also a crate that's external to our package. Because the standard library is shipped within the Rust language, we don't need to change cargo.toml to include STD. But we do need to refer to it with the use to bring other items from there into our package's scope. For example, with HashMap, we would have to use this line, which is std collections hashmap, and we have our use statement or use keyword at the front. Now, using nested paths to clean up use lists. If we were using multiple items to find in the same crate or same module, listing each item in its own line can make up a lot of vertical space in our files. For example, with these two use statements we had in the guessing game, In listing 2-4, bring items from STD into scope. We have use std-cmp ordering and std.io. Now, instead, we can use nested paths to bring the same items into scope in one line. We could do this by specifying the common part of the path, followed by 2 colons and then curly brackets around the list of the parts of the path that differ, as shown in 7-18. So you can see here we have the same, it's coming from the same module, which is the standard module. We have CMP ordering, and then we have IO in these curly brackets right here. The bigger programs, not problems, but bigger programs bringing many items into scope from the same crate or module using nested paths can reduce the number of separate use statements needed by a lot. We can use the nested path at any level in the path, which is useful for combining 2 use statements with the share of a subpath. For example, a listing 7-19 uses 2 use statements that one std.io into scope that brings std.io right into scope. Now the common part of these paths is the std.io, and that's the complete first path. To merge these paths, we use one use statement as we can use self in the nested path as shown in lesson 7-20. You can see here in the curly brackets, we have self and right here we have the standard path, IO, which both of them have in scope. So we bring both of them into scope. Importing items with the glob operator. So if we want to bring all public items defined in the path, in a path with a scope, we can specify the path with the following star glob operator. Now this use statement brings all public items defined in STD collections into the current scope. Be careful when using the glob operator. Glob can make it harder to tell what names are in scope and what a name used in the program was defined. Additionally, if the dependencies changes its definitions, you would have important changes as well, which may lead to compiler errors when you upgrade the dependency if the dependency adds a definition with the same name as the definition as yours in the same scope. For example, the glob operator is often used when testing to bring everything under test in the test modules, and we'll talk about how to write tests in chapter 11. The glob module is also sometimes used as part of a prelude pattern in the standard library documentation for the information on the pattern. Okay. This shouldn't be too long. We're almost done. Okay, and I don't even have a drink, so I can't even have a little water break, okay? I forgot to bring a drink. That's my bad. Whew. All right, you ready? Let's go. So, separate modules from different files. So far, all the examples in this chapter define multiple modules in one file. When modules get large, you might want to move their definitions into separate files to make the code easier to navigate. For example, let's start from the code in listing 7-17 that had multiple restaurant modules. We'll extract modules into files instead of having all the modules defined in the crate root file. In this case, the crate root file and source/librs, but this procedure also works with binary crates, whose crate file is source/mainrs. So first, we'll extract the front of the house module to its own file. Remove the code inside the curly brackets for the front of the house module, leaving only the mod front of house declaration so that source/librs contains the code shown in 7-21. Note that this won't compile unless we create a source/front of house file in 7-22. Okay. Ooh, my neck hurts. That is what happens when you sit at a desk all day. You become a little tech neck. And I'm not even gonna go to the side, but I know my neck is like this. Like this. Like that. You know what I'm saying? Anyway. Alright, let's finish this. So we have mod, front of house, pub use, crate. We're front of the house and hosting. Now we have a pub function, which is eat at restaurant, and hosting add to waitlist call, function call right here. Now next place the code with the curly brackets in a new file called source/front of house rs as shown in listing 7-22. The compiler knows to look in this file because it came across the module declaration in the crate root with the name front of house. So it knows that it's supposed to go in that module. So we have pub mod hosting pub function add to waitlist. So we're in this source/front of house file and we put our code within it. Now note that you only need to load a file using the mod declaration once in the module tree. Once the compiler knows that the file is part of the project and knows where the module tree and code resides because of where you put the mod statement. Other files in your project should refer to loaded files code using a path to where it was declared, as covered in path for referring to an item in module tree section. In other words, mod is not an include operation that you may have seen in other programming languages. Next, we extract the hosting module to its own file. The process is a bit different because hosting is a child module of front of house, not the root module. We'll place the file for hosting in a new directory that will be named for the ancestors of the module tree, in this case, source front of house. Okay, to start moving hosting, we change source front of house rs to contain only the declaration of hosting module. So we have pub mod hosting, and then we create source/front of house directory and hosting rs file that contains definitions made in the hosting module. Okay. Now we're in source/front of house/hosting rs, which is the file within front of house. Pub function add to waitlist is within that. So if we instead put hosting rs in the source directory, the compiler would expect that the hosting rs code would be in the hosting module declared in the crate root and not declared as a child for the front of house module. The compiler's rules for which files to check and for which modules code means the directories and files are more closely matched to the module tree. Okay, alternative paths files feel like we don't need to really go through that. You can read that on your own. Okay, we moved each module's code to a separate file and the module tree remains the same. The function calls in the eat at restaurant that will work with any modification. Even though the definitions live in different files, this technique lets you move modules to files and grow in size. To new files and as they grow in size. Note as the pub use create front of house hosting statement in source/lib also hasn't changed, nor does use have the impact on what files are compiled as part of the crate. Now the mod keyword declares modules and Rust looks at the file with the same name as the module for the code that goes into that module. Alright, this is the end of our chapter 7. I feel like, just personally, I like to see a lot of code. This is just mostly about file structures, path structures. This is a very important chapter because yes, we need to know about files, folders, directories, paths, and how to bring them into scope. Just not my favorite chapter. Just not my favorite chapter. Alright, so summary. Rust lets you split a package into multiple crates and the crates into modules so that you can refer the items defined in one module from another module. You can do this by specifying absolute or relative paths, and these paths can be brought into scope by using the use statement so that you can use a shorter path for the multiple uses of that item in scope. So module code is private by default, but you can make definitions public by adding the pub keyword. In the next chapter, we'll look at some collection data structures in standard library so you can use to neatly organize your code. So Nexus collections, I think this is vectors, yep. Vectors, encoded text, and hash maps. So I'm so excited about the next chapter. This chapter was a little bit boring. I kind of wanted to go through this one a little faster because it's just not, there's no code in here. So it's not as fun. Let me put my screen. Yeah, so this is the end of this episode. Please join us for the next episode, which is tomorrow. That's going to be our last day, so we only go live Tuesday through Friday. Check out my other lives on YouTube. If you're watching on Twitch, you can check out my YouTube, which is also called Fight Me. My lives are under the Arrow 404 playlist if you'd like to see all of them. I also have another playlist for my Rust mini projects, which I will be posting hopefully tomorrow. I'll be posting chapter 4, chapter 5, and chapter 6 hopefully tomorrow or Saturday. So stay tuned for that. Right now I only have chapter 2 and chapter 3 up, but you can find it on my Rust mini projects playlist, Smiling Friends edition, on my YouTube as well. Is there anything else I need to say? Just that I hope you have a great day, and I'm so proud of you. You are becoming a Rustacean. You are becoming a master of your craft. Go through these lives with me. Become a master of Rust, and we are going to venture off. Once we get through the fundamentals, we're going to an intermediate, and then we're probably going to very complex projects very soon. And I'm so excited about that. That's going to be longer edited videos. I wouldn't be doing that on live. So we'll see about that. Also, I want to get into more of my Solana based like SBL tokens, minting tokens. Those mini projects are going to do us really, really well when we start making smart contracts. So I'm so excited for that. Stay tuned for those. And subscribe and follow me. Alright, I'll see you later. Bye!